So today we introduced the idea of congruent triangles and congruent polygons. So our first definition applies not only to triangles, but to any kind of polygon, squares, rectangles, hexagons, heptagons, etc., right? What this definition states is that in order for two polygons to be congruent, specifically we'll be looking at triangles, they need to have all of their corresponding angles congruent and all of their corresponding sides congruent. So what we're going to have to do is we're going to have to write out every single pair of angles between two shapes and every single pair of sides between two shapes, say that they are congruent, and then using this definition, we're going to be able to write what is called a congruence statement. The tricky part here, that all seems fair, but the tricky part here is that we are going to have to line up pieces and watch our notation very, very carefully here, okay? So when I take a look at corresponding angles, do we see mine is color-coded, yours is printed in black and white, of course, so it might be a little bit harder to see. But A congruent to angle H. I see here that these each have two tick marks on those angles. I know that those two pieces line up together. If I look at the one tick mark angles here in blue, B congruent to J. And then lastly, the three tick mark angles, angle C is congruent to angle K. Those are the pieces that line up. I highly recommend when you start looking at your angles that you highlight them in different colors. So highlight the A and the H in the red, the B and the J in the blue, the C and the K in the green, whatever it is, to make it make sense to you. Because when we start talking about segments, we have to pay attention to the order that we write our segments in. When I talk about corresponding sides, I'm going to erase some of my colors here, actually. If I look at the corresponding side, A, B, it has one tick mark. I look at the other one tick mark side, right? We see them, they both have one tick mark. If I start with A, B, which was my two tick mark angle to my one tick mark angle, or if I'm looking at my colors, the red to the blue, when I name HJ, I also have to go red to blue, or two tick marks to one tick mark. Do you see what I'm saying here? I could not say AB congruent to JH because that is backwards. J is my one tick mark angle where A is my two tick mark angle. So these things line up. The order matters here. So similarly, when I look at my two tick mark sides, if I start here with BC as my two tick mark sides, I went blue to green. I have to go JK, which is also blue to green. If you're not using colors, you have to look at those number of tick marks. And then lastly, I have AC, three tick marks, red to green. HK, three tick marks, red to green. Does that make sense what I'm saying here? Once we have listed out all the angles that are congruent, all the sides that are congruent, then by using this definition, now I can write what is called the congruence statement. The congruence statement says that triangle ABC is congruent to triangle HJK. Again, we are lining up those pieces. A goes with H, B goes with J, C goes with K. The congruent statement is a very useful tool because just looking at it, I can tell exactly what pieces go together. If I wanted to look at the segment AB, it's those first two letters, I know it must go with the segment HJ. So this is a super useful thing. Sometimes it's given to us, sometimes it's not, and we have to write it ourselves. Any questions on that? I am going to be picky about the order that you are writing things in, so make sure that you understand that concept. Then we have a theorem that we're going to kind of use a little bit today. It's our third angles theorem. It's a pretty self-explanatory theorem. It states that if I have two pairs of angles, so C is congruent to K, and I know that B is congruent to J, then by the third angles theorem, that third pair of angles must also be congruent to each other. So it goes, if I have C congruent to K, B congruent to J, then A and L must also be congruent. That's all that says. Any questions there? Okay, so let's look at this. This goes for all polygons, but specifically we're going to be looking at just triangles today. Our definition of congruent polygon states I have to list all the angles congruent, all the sides congruent, then I can write my congruent statement. A lot of the times, it's already all given to us. So if I'm looking at number 1, I see the pieces that are given to me. I can line up A and J are congruent. Oops. I can line up B and K are congruent. Ooh, why do I keep doing that? And then I can line up C and L. So I've got all 3 pairs of angles. I got to make sure I can do all 3 pairs of sides. This is where we get tricky. If I go start with AB, A was my 1 tick mark angle, B was my 2 tick mark angle. I want to make sure that I do the same thing on the other side. So I should go JK, 1 tick mark to 2 tick marks. If I start with BC, then I should have KL, 2 tick marks to 3 tick marks. CA goes with LJ, 3 tick marks to 1 tick mark. Does that make sense? Only once we have 3 pairs of angles and 3 pairs of sides can we now say our congruent statement, which says triangle, and I'm just going to go with ABC here, and then make sure my other half matches. Triangle ABC is congruent to, I went 1, 2, 3 tick marks. I need to go 1, 2, 3 tick marks in my other triangle. Any questions on that? Okay, that's like a really easy one because they're separated for us. Everything was marked. Here, they're together, and not everything is marked here. So we can start with what is marked. When I see a diagram like this, I like to start by highlighting some stuff. So I will highlight like angle A goes with angle D. If you are a visual person, I highly recommend you do this too. In this triangle, angle B goes with angle C, but then we reverse it because then we also have angle C goes with angle B. Oh, I did not like that. Okay, so we see how these 2 triangles are like flipped backwards. We have to be careful that we are lining things up correctly. So let's start with the angles. The most obvious angle is this angle A congruent to angle D. We all see that? That's angle number 1. Number 2, let's go with these angles in blue here. If I'm looking at the triangle on the left side, it's angle B. If I'm looking at the triangle on the right side, this is angle C. We cannot just use one letter, however, to name these angles because there are 2 angles that start at B and there are 2 angles that start at C. I have to be a little bit more specific. So I'm going to call this angle in blue A, B, C, 3 letters. And I'm going to make sure that I line these up. So if I went pink, blue, purple, I'm going to go pink, blue, purple to name this angle right here. Angle DCB. Does that make sense what I'm saying? Okay, let's do it again. Now I need to name those purple angles. So let's go pink, purple, blue, ACB. What would the other side be then? If I go ACB, the other side is, yeah, DBC, pink, purple, blue. Oops. Questions on that? Okay, angles, we're good. Let's talk about the sides. I'm going to kind of get, no, I'll leave them actually. So when I talk about the sides, I have some that are marked, and I have one that maybe isn't marked we're going to have to find. So let's start with the ones that are marked. Hello? I can start with this one tick mark side right here, right? We see it. I'm going to go blue to pink, B to A. So what corresponds with B, A? Blue to pink, C to D. Given to me, already marked in my diagram. Number 2, I'll do the 2 tick mark sides. Here to here, pink to purple, A to C, D to B. Everybody good here? Now I've run out of givens. Where is my third pair of congruent sides? Do we see it? Yeah, Ian? Yeah, BC to CB. It's congruent to itself, obviously, in the middle here. BC and CB are literally the same exact segment. What is that called when something is congruent to itself? Dahlia? This is the reflexive property. I'm just going to write it in there just so we know that it's there and that proofs are coming, because they will be coming. Questions on that? So let's write my congruent statement now that we have everything lined up. I have triangle A, B, C, congruent to triangle. I went pink, blue, purple. I should go pink, blue, purple here. Any questions on that? Okay, you guys are really not going to like me for this one, but we got to do it. Number 3. We have tick marks. I see the tick marks, right? I have 2 pairs of segments congruent here and here. What do those arrows mean, though? Parallel. So in order to find any of my angles, I'm going to have to use these parallel lines. So let's extend them. I'm going to use the top, the bottom, and this middle line is my transversal. What angles do we get from here? Any ideas? Maybe they're hard to see. Maybe we can see them. I don't know. Do we see them? Do we see the alternate interior angles that are forming here? Hopefully. Let's start with 1 tick mark and 1 tick mark. Let's call that LKM. And let's call the other one J. Oops, I need an angle. JMK. It's going to be harder to write these at the beginning, I know. All right, we're good with that angle. Let's do the other way. These parallel lines. Hopefully we also see this pair of alternate interior angles. So that is JKM and LMK. Both of these, let me write a little reason here. Alternate interior. Okay, so I'm at 2 pairs of angles congruent. How do I get my third pair of angles congruent? I'm not going to be able to use my parallel lines this time. What can I use? It's a theorem that we maybe just learned like 10 minutes ago. Yeah? It's the third angles theorem. It states if I already have 2 pairs of angles congruent, I can get that third pair of angles congruent by the third angles theorem. So I can say angle J is congruent to angle L by the third angles theorem. Okay, beautiful. Now I got to work on the sides. I have ones that are given to me. So let's do those givens. The 1 tick marks. Oops. 1 tick marks JM. 3 tick marks to 1 tick mark for those angles there. JM congruent to LK. 2 tick marks. Let's do JK to LM. Those were given. How do I get my third angle or my third side? How do I get that third side? We just did it in the last one. I need this. Why is that? Caitlin? Yeah, it's reflexive. So remember, we have to write KM congruent to MK, and that's reflexive. Okay, totally running out of room, but now let's finish it off. Now that I have 3 sides, 3 angles, I'm going to write triangle LKM is congruent to triangle JMK. As a little shortcut, if we wrote these angles correctly, I can just copy one of those angles for my triangle congruent statement, if those angles are written correctly. All right, any questions on this? I know that's kind of a doozy, but that's by our definition. All angles congruent, all sides congruent. We will eventually get some shortcuts for that. Okay, flip it over. I honestly don't think we need to really do 4. Assume the triangles are congruent. We should just be lining up tick marks. 2 tick marks goes with 2 tick marks. I can set those equal. 3 tick marks goes with 3 tick marks. I can set those equal. Are we okay if we don't do that problem all the way? Okay, let's look at some more complicated stuff. All right, given triangle DEF is congruent to triangle LMN. DF equals x squared and M equals 5x minus 6. LN equals x plus 12. There's a lot going on here. There's 2 ways that we can approach this. The way that I recommend you start this problem is by taking 2 triangles, drawing them out, and labeling them. D, E, F, and L, M, N. Once we have these 2 triangles drawn and labeled, hopefully we can see which pieces line up together, right? We see that? As long as we kind of put our vertices in the same order, like DEF, LMN, as long as we did that, we can visually see it. Otherwise, if you're like, drawing diagrams is for babies, Miss Lease, I don't want to do that, you can look at your congruent statement and pick out these pieces. If I take a look at DF, DF is the first and the last letter. It should line up with LN, the first and the last letter. That congruent statement's kind of like a cheat sheet for me to tell me what lines up with what. Okay? So from here, now that I know that these 2 pieces are congruent, they're corresponding, I can set them equal. I have an x squared and an x. Nothing's going to cancel out, so I do have to factor this. I have x and x in the bubbles. I get something that multiplies to 12 and adds up to -1. Anybody? Any takers? Anybody want to show off their factoring? Caitlin?
Is it like -12 and +1? Or
No, we're trying to get it to add up to -1. Casper? Yeah, +3, -4. Those will add up to my -1. They multiply to -12. We set them both equal to 0. I have a negative number here. X equals -3. I want to make sure that that works in my diagram. -3 squared, that gets me a positive number. -3 plus 12, that gets me a positive number. 5 times -3 minus 6, does that get me a positive number? Nope. So that automatically makes -3 extraneous, or not one of our solutions. So our only solution here is x equals 4. Questions on that? All right, number 6. Given triangle ABC is congruent to triangle NTE. Let's first figure out the measure of angle E. Oh, we can figure out the measure of angle E. Okay, so let's look at the measure of angle E. Where is E in our congruent statement? It's right there at the last spot, which means it should line up with C. E and C. Oh, wait, I don't have C. How do I get C? How do I figure out what angle C is? Allegra? Oh, I don't even need to do all that. That's too much. Caitlin? Exactly. Don't make it too hard on yourself. 180 is our magic number for triangles. Subtract those other two angles, 62 and 84. I believe, what do we even get? I don't know. Oh, I didn't even find it. What is it? 148. So I'm looking at 32. Is that right? Mental math, not my strong suit. Questions that one? Now define X. The only thing that I have with X is AB, this segment right here. So AB, first two letters, NT, also the first two letters. So those two pieces must correspond. X squared minus 6 equals 10. Here's the difference between the one that we just did before in number 5 and this one right here. This one only has an x squared. There's no x. So I don't have to factor this one. I can add 6 to both sides. X squared equals 16. I square root both sides. What do we need anytime we square root both sides? Dahlia? Plus or minus. And then I'm going to check, because I always want to check my negatives. Does it work here if I do negative 4 squared minus 6? Well, that's 16 minus 6. That's still a positive number, so I'm okay with that being negative. Any questions there? Okay, I'm going to do more skipping. 7 is a factoring problem. I'm going to skip it. You're welcome. Let's look at 8 really quickly because I think it's just a weird one that we might get scared of. I have 2 overlapping triangles. They often overlap our triangles to try to confuse us. All we have to do to take care of this is draw them out separately. That's what I do, at least. I have A, B, C, and then I have D, C, B. I'm going to line up my pieces, so maybe I'll even do it in colors. Let's line up A and D, looking at my congruent statement. These two. Let's line up B and C. Oh, wrong order. B in my first triangle, C in my second triangle. And then let's line up C and B. A little bit easier to understand now that we've drawn them out, highlighted them, given them a little bit of color coding. So this says ABC is 110. So this angle ABC, where B is my vertex, is right here. That's 110. So I know then that C must also be 110 over here. Angle D is 20, which means this angle A must also be 20. How am I going to figure out those last 2 angles down there? How do I figure out what the remaining angle is? All 3 have to add up to 180. So I do 180 minus 20 minus 110. That gets me, 130, so 50. So this is 50 degrees. This is 50 degrees. To answer my question, the measure of angle ACB is the same as the measure of angle DBC, and they equal 50 degrees. Any questions on that?